processing and analytics system using multiple microservices, using Docker containers, indexing, query, and automated report generation. In this video, I quickly explain the folder structure, important files, and how the complete pipeline works from log generated to report creation. The first one is project root files. Let's look at the root level files. The first one is env.example. This file contains environment variables, example used for configuration. It helps developers easily set up the project locally. And the next one is .gitignore. This file prevents unnecessary fields like catch files, virtual environments, and generated files from being pushed to Git. And the next root file is docker compose.yml file. This is one of the most important files in the project. It defines all services and containers required to run pipeline together. Using Docker Compose, the entire system can be started with a single command. The next file is readme.md5. This file contains project documentation, setup instructions, architecture, explanation, and usage details. Next, benchmark.sh file. This shell script is used for performance benchmarking. It helps measuring indexing and query performance. And the next one is benchmark results.txt. This file stores the benchmark execution results. It helps compare performance and analyze system efficiency. These are the project tools files. Now, moving to the data section, data and index structure. Data documents. This folder contains multiple JSON log documents. Each JSON files represent generated or collected log data. These logs are later processed and indexed. The next one is data index. In the in that index file, we have inverted index.json file. This file stores the inverted index. The inverted index improves search performance by mapping terms to document locations. This makes querying extremely fast. Now we see log generator services. Let's look at the log generator services. Log generator main.py file. This Python file generates sample logs automatically. It simulates real world systems logs like authentication, logs, payments logs, inventory logs, and server logs. The next one, requirements.txt. This file contains Python dependencies required for the log generator services. Next one, Dockerfile. This Dockerfile creates the container image for the log generator services. Next is the ingester service. Here we have main.py file, Docker file, and requirements.txt file. Let's first we see the main.py file. This services reads generated logs and ingest them into the processing pipeline. It acts as the entry point for the data collection. The next requirements.txt file. It contains required Python packages. Docker file. It defines the container setup for the ingester service. Now we move to the indexer service. Sorry. The indexer server is complete. Service is completed. Next is the query service. This query service have query.py file, requirements.txt file, and docker file. Let's first we see the query.py file. This file handles search queries. Users can search logs quickly using indexed data. The query engine retrieves matching log entries efficiently. Next one is Docker file inquiry service. It defines the Docker container for the query service. The next one requirements.txt. It contains dependencies used for query. Now let's see the scheduler and reporting modules. In scheduler, we have report.py file. This file generates automated reports from analyzer logs. It helps monitor system activity and detect patterns. The next one is requirements.txt. It contains dependencies for report generation. The next one is Docker file. It creates the schedule container. Now let's see the reports file. This folder contains generated reports. Example, auth service.json, cron.json, inventory service.json, kernel.json, nginx.json, payment service.json, sshd.json, user service.json. These reports summarize logs from different services. So overall, this project demonstrates a complete log analytics workflow. The pipeline includes log generation, ingestion, indexing, fast querying, automated reporting, and containerized deployment using Docker. The modular microservice architecture makes the system scalable, maintainable, and easy to deploy. Thank you.